Hello everyone, good morning. For this given practice exercise, we are tasked to determine the measurements of the rest of the specific parts of an oblique triangle given the specific situations. Before we start, let us not forget that an oblique triangle is a triangle with no 90-degree angle. In short, it could have acute angles or obtuse angle as long as one of the interior angles is not a 90-degree angle or a right angle. To solve for the unknown measurements of these given figures here and the given situation on number 3, we need to understand the given per situation so that we could determine what process we need to use. To solve for this, we have here the law of sines. The law of sines is one of the formula created for us to solve the unknown measurements of an oblique triangle given a specific situation. And the law of sines could only be possible to be used in three different situations, two of which is present here. I'm going to talk about the last one on the next video, on the next practice exercise. The law of sine tells us that the ratio between the sine of an angle, let's say angle A, and its opposite side is equal to the ratio of the sine of another angle to its opposite side, which would also be written as another ratio sine C over C. Take note that the capital letters here are used to denote the vertices of a given triangle, and hence it tells us the angle. However, the small letters here pertains to the side directly opposite the specified angle. So in this case, if we talk about sine A, which includes vertex A and the angle A itself, the value of the small letter A is this side here. Same as true with B, and its opposite side is here. So that's already given as 4. And letter C is the opposite side here. Now for number 2 and number 3, we are no longer using ABC, but the concept still holds true. This formula for the law of sine could also be flipped in such a way that the measurements of the small letters are on the numerator while the sine of the angle is on the denominator. Or you could write it this way: A over sine A is equal to B over sine B, and it's equal to C over sine C. These are all possible because of the fundamental law of proportion, which tells us that we could manipulate it using the products of the extremes and the means, and it could go with this way. Just make sure that if your numerator is a sine of an angle, the numerator of the second proportion, or ratio rather, and the third ratio also contains the sine of an angle on its numerator. And the sides, since it's the first given is on the denominator, the sides measurements are also a denominator. And if you're going to flip it, make sure that you do it the same way. This is the law of sine, and we have actually a derivation for this. I may be making a separate video for that, so you may want to check that one as soon as it will be available. So we can apply here the law of sines to solve the specific situations here. As we go through item number 1, 2, and 3, we are also going to highlight specific types of oblique triangles that can be solved under the law of sines. In this given figure here, number 1, we have triangle ABC with given angles A, which is 54 degrees, and the measurement of angle B, which is 43 degrees, and the side measurement of AC, which is 4 units, which is also the value of side B, as this is the side opposite angle B. In this specific situation, we can notice that one of the pairs in this proportion is given. That is actually the value of B, which is 4, and the angle B, which is 43 degrees. Or if you would like to use this formula, you can also use this to determine the result. The law of sines could be used to solve for the remaining measurements of this oblique triangle because of that given situation. Again, that is where one side measurement is given together with its opposite angle, or vice versa. The angle is given together with its opposite side measurement. With this, we are assured of that one of the ratio here is known. And with regards to the remaining given, we can use our fundamental law of proportion to solve for one given and the rest. This is an example of a AAS situation. AAS because we have two angles given with a side that is not included between them. When you say included side, it should be this side here, C, as it is the side between the two measurement of angles. So again, this is AAS. AAS, or others will just also mention SAA. But let me just do it this way to highlight the given angle. When we have ASS given for an oblique triangle, we can use the law of sine. This is the first situation where we could use it to solve for the remaining. Before we could use this formula here, we could solve first the third angle here, which is angle C. Please be reminded of the triangle angle sum theorem, which tells us that the sum of the measurements of all interior angles in any triangle is 180 degrees. That would mean if we are going to add the measurement of angle A plus the measurement of angle B plus the measurement of angle C, it must be equal to 180 degrees. This is convenient to be solved, I mean measurement of angle C, because we already given with the measurements of angle A and angle B. So you're just going to substitute it. You will have here 54 degrees plus 43 degrees plus the measurement of angle C is equal to 180 degrees. And you could subtract both sides. We have the measurement of angle C is equal to 180 degrees less 54 degrees less 43 sorry, that's 43 degrees. You could just solve this manually, or of course you could also use calculator for this. So we have this calculator here. You have 180 minus 54 minus 43 degrees. You will have 83 degrees as the measurement of angle C. So we are done with the first unknown measurement. Notice that we have three angles and three sides in a triangle. So we have determined already the third angle to complete the interior angles. What's next to be done is the identification of the measurement of side A, which is actually side BC, and side C, which is side AB. To do that, we are going to use here the law of sines. Let us try to use the first two ratio as part of our first proportion. You could either use this or use this one. It's up to you. They must have the same result whether you will use which of the two. So let's use this one here. So you will have given here sine A, and sine A is actually, or A, angle A measures 54 degrees. Okay. All over the measurement of A, which is a known, which is equal to sine B. So you have here sine B, which is 43 degrees, all over the measurement of B, which is 4. In this case, or in this example, we don't have a unit of measurement, say centimeter, inches, or meters. So we are just going to use units later, or we're just going to use 4 as it is as of the moment. Now take note that in this given, we have only one unknown. This is the reason why we could use the law of sine, because one pair of angle and its opposite side is given here. So you can just simply manipulate this. You could use the fundamental law of proportion. The product of the extremes is equal to the product of the means. You will have 4 sine 54 degrees. I am encouraging you to use properly your notation. Some of us before are using sine 54 degrees times 4. Then if you're going to input this in your calculator, it might automatically mean that you're multiplying 54 degrees by 4. So it will become sine 216, if I'm correct, degrees. So make sure that you don't do that. Make sure that 4 is a constant and sine 54 degrees is one expression equal to a sine, a is unknown, 43 degrees. And you could divide both sides by 43 degrees. You will have here a using symmetric property 4. You will have sine 54 degrees all over sine 43 degrees. Okay? If you're going to input this in your calculator, let us not forget that when you solve this, rounding off of answers per expression is not necessarily allowed because you might create an answer which is far away from the exact value or approximated value. In this case, we are suggesting that you use here calculators, and if you can, use calculators where you could input all of this expression as one. Since we are doing online classes, of course, we could always encourage you to use calculators. Even face-to-face classes, we're encouraging you to use calculators. So if you have there your calculator, you may use it. On my case, I'm going to use instead this calculator which has no other functions, or I could also manipulate this in such a way that it could include those trigonometric functions, or I could always go to the internet and click this one here, scientific calculator online. So I have here this value. So I'm going to minimize this. Okay. So I have here the expression. Okay. Make use of parentheses to get the value of a 4. Okay. Uh, Sorry, let us repeat it. You click AC to remove everything. So you are going to have double parentheses 4. And we have here sine 54 degrees. Close it. Another parenthesis to make sure that it's an expression to be divided by sine 43 degrees. Close it. So you have 4 times sine 54 degrees divided by sine 43 degrees. You click equals here. You will get 4.74, 497, so on and so forth. So in this case, we are going to have an answer which is rounded off into 2 decimal places as agreed on our classes. So let's round it off. So we have 4.74. So I'm going to use here this expression, approximately equal to 4.74. So this is the value of A in this given expression here. Notice that it happens like this. Now, if you're going to use this expression, it's actually easier to look at. Let me show it like this. Right? So you're looking for A all over sine value of A, which is angle A, which is 54 degrees, is equal to B, which measures 4 all over sine 43 degrees. You could just apply immediately the fundamental law of proportion, or just multiply both sides by sine 54. You will get the result here, which is A is equal to 4 times sine, sorry, that's sine, sorry, undo sine, yes, sine 54 degrees all over sine 43 degrees, which is actually the same as this expression here. So any of the two could be used to solve for this one. So you have here this result, 4.74, using the computation. My concern is for some of us, again, let me go back here. I'm going to erase all of this by clicking AC. So I'm going to have 4 times sine 54. Okay, so we'll have, if you're going to round off, if you're going to round it off, you have 3.24. Okay, let's make it clear. You have 3, this one, 0.24. And for the denominator, you will get an approximated value, which is sine 43, which is 0.68. Okay, round it off to 0.68. Okay, as you divide this, you may still get the approximated answer here. But for the rest, for some computations, this might be, let's say, 73, 75, or worse, 70 or 79 in that case. So let's just try to check this one. Divided by 0.68. Okay, so look at this one. 4.76. This is the result when we divide the two approximate values for this, and then you will get 4.76. Now, which is more acceptable? In some instances, 4.76 is also acceptable as we are rounding off. But as we have agreed in our class, we are not going to round off in a process because we might have a different answer. So we are just going to do rounding off for the last. Okay, so it's not 4.76, it's approximately 4.74. This is the value for A. We are not yet done with number 1. This is the value for A. So we have to solve the value of C, which is the last value here. So you could pair any of the ratio here. But this is my hint for everyone. I'm going to give you a hint. You could always use the pairing of sine A and A with this ratio here to get the value of C if you would like to. Now, here my advice to everyone. If you're going to do it like this, there might be some errors because notice that A earlier is just an approximated value and you solve this as you use the process. If you have different answers here, more or less what you use is 4.76, it will also affect the value of the measurement of side C or side AB in this case. So what I am suggesting to you is use the given that has a proper pairing already. Okay? Even if we are confident about our answers in A, it might affect the answer for C later on. My point here is, among the given here, it is the pair of sine B and side B which is given. So instead of using A, we are going to use this expression to solve for C. Okay? So instead of doing it like that, so we are going to use the measurement here, sine. Let me use another color to differentiate them. You have sine B all over B, side B rather, and the sine of C over C. Okay, so sine B, B is 43 degrees. So we'll have here sine 43 degrees over 4. That's 43, pardon my handwriting. Okay, is equal to sine C. C is not necessarily given earlier, but we have solved it into this one, 83 degrees. So let's have 83 degrees all over the unknown C. So we use the fundamental law of proportion. You will have C times sine 43 degrees is equal to, again, use the proper notation, 4 sine 83 degrees here. And divide both sides by sine 43. The value for C is computed as 4 sine 83 degrees all over sine 43 degrees. So using the same calculator, let's solve it without rounding the results per process. So I'm going to use multiple parentheses to denote grouping. So I'm going to have here 4 times sine 83 degrees. Okay, that's for the numerator. Or maybe it's more than that. Yeah. Divided by, let me check. So I'm going to erase, let me repeat. I can just simply use 4 times sine 83. That's it. Divided by sine 43 degrees. And you will have the approximated result to 5.82. So same thing if the value earlier was given with units, so we're going to use centimeters, inches if there are. You could also name this units, 5.82 units, same as here, units. Or 5.82 is already okay. Yeah, it's acceptable. So this is how we answer number 1. We have solved the unknown measurements using the sign or the law of sine. Okay? But measurement of angle C can be solved already using the triangle angle sum theorem since two angles are already given. This first situation is under AAS. And if you see a situation later with the same AAS, you could always use the law of sine. Let's proceed to number 2. Number 2 is where given angle is 76, you have here 9, and you have here 34. If you're going to examine this one, this is under ASA, ASA, because you have here an angle, included side, and angle. Earlier it was AAS because the side is not between the two angles, or it's not included side. Here it is now included side. In this manner, we can still solve here this one using the law of sines. Even if it doesn't have enough pairing, we can solve this because we could always use the triangle angle sum to solve for angle E. So the triangle angle sum theorem tells us that the sum of the three angles, you have here 76 degrees plus 34 degrees plus the measurement of angle E must be 180 degrees. So the measurement of angle E, okay, let me use this first calculator. Okay, so we'll have here 180 degrees minus 76 minus 34. You will get a 70-degree angle for angle E. Now that we have solved the measurement of angle E, we can use it and pair it with this side here, which stands for a small letter E. And pair it with any of the two to solve the other sides. F is actually a point here, is side small letter D, and this side small letter F. So don't just be bounded with A, B, C's, okay? If your vertices are different, definitely you're also going to change your formula or just apply the correct substitution. So let us try to solve D first. And we would like to solve D by pairing the measurement of angle D to this side as given, but measurement of angle E was solved earlier, together with this. So I will have here sine 70 degrees for this here, all over 9 is equal to sine 76 degrees all over D. Apply the fundamental law of proportion, you will have D times, it's okay to have no parentheses since it's a variable, degrees is equal to 9 times sine 76 degrees. And you divide both sides, you will have D is equal to 9 times sine 76 degrees all over sine 70 degrees. Use the other calculator. So you have here AC to remove everything. You will have parentheses for the numerator 9 times sine 76 degrees, close, divided by another parenthesis. Okay, sorry. Divided by sine 70 degrees. Sorry, that's not 0. How would I did it change this? Oh, yeah. 70 degrees. So as you input equals and round off to two decimal places, you are going to expect that D is more or less 9.29. This is the value for side D. Okay. So you have solved already 2. The remaining is for F. So again, as suggested, you may use D, but if there are errors, it's safe to use what is given here. So you could use here sine 70 degrees all over 9 for E, angle E and side E is equal to sine 34 degrees all over F. And then apply everything. Let's jump immediately, okay? This is 9 sine 34 degrees all over sine 70 degrees. And F could be approximately, okay? So you have, let's just change this one here, okay? So 34. Sorry. I thought I was just changing it. So let us do it again. 9 times sine 34 degrees. By the way, the changing of value was not made possible because I already clicked equals earlier. Divide by sine 70 degrees. So you have 5.36. Again, rounding off. Okay. So you have 5.36. This is the value for your F. So we have solved the remaining measurements of this triangle here, DEF. Before we proceed to number 3, which is our last example for this practice exercise, how do we know if our answers are correct? Okay, we just need to depend on our learning in grade 8 where we identified that the bigger the angle on a triangle, the longer the side. So to use that concept, let us try to determine whether the bigger the angles here, the longer the sides, or the smaller the value of the measurement of the angle and the shorter the side. Notice that our biggest angle here is 76 degrees, since angle E is measured at 70 degrees. So 76 degrees is for angle D. In short, side D must be the longest side. And side D is measured to be 9.29. It's longer than 9 here and longer than 5.36. The next angle, which is the next to 76 degrees, is angle E, which is 70. That's why it's 9. And finally, angle 34, angle F, which is 34 degrees, it has a shorter opposite side, which is 5.36. Doing the same for number 1. Here, the biggest angle here is 83 degrees, angle C. And side C measures 5.82, longer than 4.74, which is A, and even B, which is given to be 4. Okay, so again, the biggest angle here is angle C, so 83 degrees, followed by angle A and angle B. Hence, it should be C, A, and then B. So that's one way of checking whether your answers are correct or not. Let's proceed now to the last item. And this last item doesn't have any figure anymore. What we need to understand here is the pairing of the sides and the angle measurement. We have used that concept that the capital letter represents the angle and its smaller letter, its lowercase, represents the side. This is what type of angle, oblique angle? Is it AAS, ASA, or what else? Because if it's not AAS or ASA, probably we might have a different way of solving this. But notice, you have here angle X, rather side X, angle Y, and angle Z. So if we're going to draw it, okay, so if this is Y, if this is Z, this is X. This is given, angle Y is given, angle C is also given, and side X. And we know that side X is directly opposite the angle X here. So this is an example of an ASA situation, still solvable under the law of sines, as similar to number 2. So in this case, let's just try to pair them with one another. So let us use the law of sine. Let me just pair it. However, Similar to number 2, we need to solve first the remaining angle because it should be the angle to be paired with given side x. So we have here the measurement of angle x is 180 degrees to be subtracted by angle y, which is 87 degrees, and angle z, which is 42 degrees. And you will have 180 minus 87 minus 42. You will have 51 degrees. This is the measurement of angle x. And per observation earlier, according to the checking, we know now that the measurement of angle y is 87, the largest. So side y must be the longest. Okay? And the measurement of angle z is the smallest angle measurement. So the side z must be the shortest. Not necessarily exact on my figure here. But nevertheless, let's just continue. We could pair sine x by its side x together with sine z over z. Or you could also have here the other one, sine x over small letter x is equal to sine y over small letter y. So these are the two situations now to solve for the further measurements of sides. So let's continue with this first. You have here sine x, which is solved to be 51 degrees. Sorry, that's 51. Divided by x measurement, which is 19. As given here, that's 19. Equal to sine z, which is 42 degrees according to the angle measurement, and it's the z that we don't know. Apply the fundamental law of proportion. You could have a result here, which is z, pardon, let me increase here. Z is 19 times sine 42 degrees all over sine 51 degrees. And z is approximately, we have 19, parentheses, 19 times sine 42, close, like that, divided by sine 51 degrees. Equals, you will have 16.36. 16.36. Okay, this is for side Z. For this area here, so you have sine, so we have sine x, which is 51 degrees, divided by 19 still, all over, are equal to rather, sine y, which is 87 degrees, all over the value of y. So manipulating that, you will have y 19 sine 87 degrees all over sine 51 degrees. And that is, let's check it here, 19 times sine 87, close, divided by sine 51. We have 24.41. So y is approximately equal to 24 point, was it 41? Yeah, 41 units. This is the answer for y. Okay, so we have solved the remaining angle and the other two sides. Let's check whether our answer is correct or not. According to the measurement of angles, the biggest angle is angle y, and then followed with angle x, which is 51. And you have here angle, measurement. Let's use measurement rather. Okay, kasi we are using inequality symbol. So the measurement of angle Z. That would mean side Y should be the biggest. Next would be side X. And the smallest, or the shortest rather, is side Z. Let me check. 24.41, 19, 16.36, and that's correct. This is this process is actually correct. So this is the first part of solving oblique triangles, or the unknown measurement of the remaining parts of an oblique triangle using the law of sines, which could be used for AAS situations and ASA situations. How about other situations, sir? So we will have a different video for that. So please wait for that video and please stay tuned and enjoy. Use this as part of your preparation. Goodbye, everyone.